Please begin today's notes session by completing these 3 warm-ups. We'll discuss these 3 questions at the beginning of class tomorrow. Alright, solving exponential and logarithmic equations. Today what we're going to use are properties of logs to help us solve these problems carefully. Condensing this log, I get log base 10 of 50x divided by 2. Simplifying the argument, I get 25x equals 2. Recall up to this point we would notice that the logs had the same base on both sides, drop the logs, and what was left was our answer. Today that can't be the case, so instead what we've got to do is we've got to use that switch into properties of exponents, or switch into the exponent version, and that's going to be 10 squared equals 25x. Dividing both sides by 25, I get 100 divided by 25, which is 4. When you're checking for extraneous solutions, you're checking for numbers that will make the argument of any of the logs in the original function or the original equation negative. That's what you're looking for. So by putting this 4 into this argument, I get the number 2, which means it's not negative, so that means it's not extraneous. Let's continue on to make sure that we've done it correctly. So we condense the log down and we get 50 times 2. And log base 10 of 50 times 2 is 100 equals 2. So 10 squared equals 100. Checks out. Question number 3. I'll be doing the left-hand column of this notes page. You'll be doing the right-hand column of the notes page. Please be ready with your problems tomorrow at the beginning of class. So we're going to condense this logarithm using properties of logs. X squared minus 9, or sorry, x times x minus 9 equals 1. Log base 10 of x squared minus 9x equals 1. Switching it into its exponential form, x squared minus 9x, bringing this to the other side, making a factorable trinomial. X minus 10, x plus 1 will be our 2 factored forms. So our possible solutions are x equals negative 10, x equals positive 10, and x equals negative 1. When checking for extraneous solutions, we're looking for the value that makes any of these arguments negative. If you put a negative 1 in there, it makes it negative. Also, if you put the negative 1 there, it makes it negative. So that means negative 1 is not a solution. 10 is the only solution to this problem. Question number 5. Instead of doing any condensing, we're simply going to switch it into its other form. 16 to the 3/4 power equals x squared plus 2x. That's 8 equals x squared plus 2x. Moving the 8 to the other side gives me a factorable trinomial, and my factored binomials are x plus 4, x minus 2. When checking for extraneous solutions, we're looking for the value that makes the argument negative. So I'm going to go ahead and put negative 4 into a squared value. That gives me a positive 16. 4 times 2 is 8, so 16 minus 8 is still a positive number. So that means both of these will be a solution to this particular problem. Number 7. Properties of logarithms to condense this into a single log. Log base 7 of 5x plus 5 divided by x squared minus 1 equals 0. Switching it into exponential form, I get 5x plus 5 divided by x squared minus 1. That equals 1. I'll be multiplying both sides by x squared minus 1. Now I get x squared minus 1 equals 5x plus 5. Moving these two values to the left side of the equation, I get a factorable trinomial, which becomes x minus 6 x plus 1. My two possible solutions are x equals 6 and x equals negative 1. In this problem, 6 is the only solution. First person tomorrow to give me the answer or the reason why will get a free bathroom pass. So think carefully about that and be ready to share your answer. Finally, what I'm going to do here are two different methods for solving the same exact problem. Regardless of which way you choose, you will get the same result. And that's what I want to show you. The first method involves moving this entire logarithm to the other side of the equation. Since it is subtraction, I'll move it back to the other side using addition. Log base 3 of x plus 3 plus log base 3 of x plus 5. That gives me log base 3 of x plus 3 times x plus 5 equals 1. 3 to the first power equals x squared plus 8x plus 15. Subtracting 3 to both sides gives me the factorable trinomial of x squared plus 8x plus 12. I will stop at this point because I want to show the other way and how these two divergent trails come back together at this trinomial here. The second method that you can use to solve this is by looking at this value 1. Using logarithmic properties, you know that I can change this back into log base 3 of x plus 3 equals log base 3 of 3. Remember, that's 1. Minus log base 3 of x plus 5. Now I'm going to use properties of exponents here to help me solve. Log base 3 of x plus 3 equals log base 3 of 3 divided by x plus 5. Drop your logs from both sides and multiply x plus 5 to the other side of the equation. So now I get x plus 3 equals 3 times x plus 5. And now I get the exact same factorable trinomial as I did the other way. Regardless of which method you choose, both will get you to the right answer. It all depends on whether or not you recognize that the number 1 is the base of the logarithm raised to the same argument. Alright, the factorable response here is x plus 6 and x plus 2. I've got two possible solutions, x equals negative 6, x equals negative 2, and I plug this in. Negative 6 will give me a negative result in both of them, therefore the only solution is negative 2. Please make sure that you've completed all of your problems in the right-hand column prior to coming to class tomorrow.